Okay, so for these practice problems, they just ask you questions pertaining to what we just saw. So I kind of have my notes over here too that I'll reference as well. So here it says, tell whether the information in the figure allows you to conclude that point P lies on the perpendicular bisector of Ln. So we're trying to determine whether this line here is a perpendicular bisector. So a perpendicular bisector is perpendicular, like it has a 90-degree angle, and it also bisects that side. So for the first one, we're shown the 90-degree angle, cool. It also shows that this side is the same as this. Therefore, we can say that this is equal to this, and yes, PN is a perpendicular bisector because of the converse of perpendicular bisector theorem. Then for number 2, it wants to know whether this is a perpendicular bisector. It shows the 90-degree angle, which is something we need. We also need to know that Ln is equal to Nm, or we need to know that Lp is equal to Pm, and it doesn't tell us any of that. So no, we can't prove that this is a perpendicular bisector. We need to know that either Ln equals Nm, or we need to know that Lp equals Pm to prove it. So number 3, this line here is at a perpendicular bisector. It definitely shows that it hits at the midpoint, but it could be a median, and we don't see a 90-degree angle labeled. So no, we can't prove it. We need to know that PN is perpendicular to ML to prove it. So this is what we need to know. And then for 4, it shows that this is equal to this is equal to this. Cool. Based on that, we can use the converse to prove that this is a 90-degree angle. So yes, converse of perpendicular bisector theorem. Okay, so then they bring in the math, and the math is actually the easier part of all this. I know the vocabulary can be kind of a lot, but the math is pretty simple. It's just a bunch of equal parts. So here it says in exercise 5 through 8, find the indicated measure, explain your reasoning. It wants to know the length of GH. So just identifying it in our picture, we need to know the length of this line right here. Since this is equal to this, we have that perpendicular bisector. That means that this is equal to this. And so GH would be 4.6. No, 4.6. And then for number 6, it wants to know the length of QR. So this little part right here, well, it shows perpendicular. It shows these are equal. So therefore, these two are equal. So if this is 1.3, then QR is 1.3. Pretty easy, right? It's just like equal parts. And then for 7 and 8, same idea. They bring in some algebra. They show these are equal, perpendicular. So therefore, this would equal this. We can just set these equal to solve for x. And for this one, it wants the length of AB right here. So once we find x, we have to plug it back in. But we'll start out 5x equals 4x plus 3. To solve this, we need all the variables on one side. So I subtract this. X equals 3. But remember, it doesn't want x, it wants the length of AB. And AB equals 5x. So 5 times 3, 15. Number 8, moving right along. Number 8 shows these congruent, shows perpendicular. That means that these two segments are going to be equal. It wants to know the length of UW, so that would be this segment. In order to find that length, we need to find x first. So we're going to set these two equal to solve for x. I'll leave myself a little bit more room here. So 7x plus 13 equals 9x plus 1. I'm going to put the variables on the same side. And then once we have x equals 6, we need to plug that in here. UW equals 7 times 6 plus 13. We get 55. Toot. Okay, so now we're going to transition over to angle bisector. So remember with the angle bisector theorem, if these two lines are congruent with these 90-degree angles, that means that this is an angle bisector. Or if this is an angle bisector, then these two segments are equal with these 90-degree angles here. So looking at this, it says, tell whether the information in the figure allows you to conclude that EH bisects FEG. So we want to know if this bisects that angle. Well, here, these two segments are the same, and you have the 90-degree angle, so those two conditions are met. So then, yes, because of the converse of angle bisector theorem. Then for 10, it shows these two segments are equal, but it doesn't show that these are perpendicular, so there's not two conditions met to prove that EH is an angle bisector. So no, we need to know that HF is perpendicular to FE, and HG is perpendicular to EG in order to prove that that's an angle bisector. Okay, and then the next page, it just continues that same concept actually on the top of the next page. Here it says, tell whether you have enough information that allows you to conclude that dV is equal to dC. Here, no, because you need to know that this is equal to the, like, has a 90-degree angle, and then you can say that dV is equal to dC. So you need those 90-degree angles. And then here, it shows angle bisectors, it shows the 90-degree angles, so therefore, yes, you can say that these are equal in length. Angle bisector theorem. Okay. And then brings in the math, which is like the easy part for these. For 13, measure of ABD. So it wants to know this little angle right here. Well, it shows these are equal. It shows 90-degree angles. So therefore, we can say that that's 20 degrees. It's equal to this. That means that this is an angle bisector and those two are equal. And then 14 wants to know the length of PS right here. Well, angle bisector, 90-degree angle, so therefore this must equal this, and then PS would be 12, the same length as the other segment. (15 and 16). Same idea, just bringing in some algebra. This is equal to this, so to find x, we're going to set them equal. X plus 11 equals 3x plus 1. Put the variables on the same side and the constants on the same side. X equals 5. It's asking for the length of FG right here. So we have to take this 5 and plug it in. So FG equals 5 plus 11. FG equals 16. And 16 KJL wants to know this angle measure. These two are equal, so we can put 7x equal to 3x plus 16. Subtract 3x. X equals 4. It wants to know the measure of the angle though, so we have to plug that in. AL equals 7 times 4 equals 28. Oh, KJL, sorry, I don't know why I forget JL. KJL. Yeah, anyways. What's that? Yeah. Sorry, I know I'm going a little bit fast because I know I'm like battling your boredom. Okay. 17 and 18, error analysis. It wants to know what's wrong with the statement. Describe and correct the error in the student's reasoning. Because AD equals AE, AB will pass through point C. You also need to know that you have like the 90-degree angles. Let's see if they put that in here. You need to know either like actually and AB is perpendicular to DE. And then number 18, by the angle bisector theorem, x equals 5. What else? Need to know that CB is perpendicular to BP. Need CB is perpendicular to BP. Great. This bottom section, it takes it up to more of like a level 4 or maybe 5. I know there's students in here that can do this. So I'm going to go over just one of them. So that way I'm not leaving anything out because I know there's students in here that will be able to achieve that. We're just going to do number 19. This little arrow here means that it's a problem, like a good example problem. And we're going to cross out these here. Okay, so let me explain it. It says write an equation of a perpendicular bisector of a segment with the given endpoint. So here it shows MN. So let's, just to explain the concept, we have like point M and N. And this would have like an equation like y equals mx plus b with a whole like slope and everything else. And then we need a segment that is a perpendicular bisector. So that bisects the segment and is 90-degree angle to that. So it's going to go through the midpoint of that segment and it intersects at a 90-degree angle. And then we need an equation of a line of this. Okay, so how are we going to go about doing that? Well, first we need the slope of this line because the slope of the perpendicular will be the negative reciprocal of that. So the first thing we're going to do is find slope of these two. So we're going to find slope. And the equation for slope, it's on the reference sheet if you don't have it memorized, y2 minus y1 over x2 minus x1. So like everybody needs to write this down, please. A lot of these concepts are big on like the SAT, PSAT, and all that, so pay attention. Okay, so you have our points labeled. You have our equation for slope. M equals -1 minus 5 over x2 is 7 minus 1, -6 over 6. So slope is -1. So for perpendicular lines, slopes are negative reciprocals. What does that mean? So we've seen this before, if you don't remember. So like the slope of one line would be like 2/3, and then a line perpendicular to it would have a slope of -3/2. So it's the opposite sign, and then you like flip the fraction. So our slope right here is -1. So that would be like -1/1. So we have to flip that. So just like 1/1, and then it's the opposite sign. So our slope of a perpendicular line would just be +1. Okay, so the slope of this like blue line is going to be +1. So we can plug that into our equation. Y equals mx plus b would be 1x plus b. But we need like a y-intercept. The way to get the y-intercept is to plug in a point on the line. Well, the only point that we know that is on this line is this midpoint of mn is on this line. So we need to find the midpoint of m and n. So I know I'm jumping for a lot of you, so we need midpoint. The equation for midpoint, x1 plus x2 over 2, y1 plus y2 over 2. Sorry. And then using these points, that would be, I'm running out of room. Okay. X's, add the x's 1 plus 7 over 2, and the y's 5 plus -1 over 2 gives you 8 over 2 and 4 over 2, which would be 4 and 2. So this is our midpoint. Comma, there's supposed to be comma there. Like parentheses if you want to be technical. So our midpoint is 4, 2. And then that is what we're plugging in for x and y. So that's what we're plugging in here. So we would write 2 equals 1 times 4 plus b. If you were good at algebra, this is making sense. If you weren't, it might not be. But it is what it is. Okay, so -2 equals b. And so then we plug this in to this equation here. So like y equals 1x minus 2. And that is our equation of a line for the perpendicular bisector of MN. Now we're real smart. There aren't any like that on the homework, but I wanted to go over one.